In this video, we are looking at response models in FastAPI, the mechanism that lets you declare the exact shape of data your endpoint returns, filter out fields you never want to expose, and get all of that documented automatically in your OpenAPI schema. By the end, you will know how to use it, why it matters, and when to leave it out. Imagine you have a user model that stores a hashed password alongside the username and email. When a root handler returns that model directly, FastAPI serializes every field, including the password hash, straight to the HTTP response. There is no automatic filter. You have to remember, on every endpoint, to pop those fields yourself. That is easy to forget, and forgetting it is a security bug. On top of that, your OpenAPI docs have no idea what shape you intended to return, so they are either wrong or missing. Think of a hotel's internal booking record. It contains the guest's full credit card details, internal staff notes, and the wholesale room cost, none of which should appear on the printed receipt. The front desk clerk applies a receipt template. Only the safe relevant fields make it onto the paper handed to the guest. A FastAPI response model works exactly the same way. It is the template that decides what leaves the building. The key piece is the response_model parameter on the path operation decorator, that is the @ decorator like at app.get or at app.post. You pass it a Pydantic model class, not an instance. FastAPI then does three things automatically. It filters the data your function returns, so only fields present on that model are included. It validates those fields using Pydantic, and it registers the model in your OpenAPI schema, so the docs show the correct output shape. Your internal data model and the public response model are kept as separate classes, which is the whole point. Let us walk through this line by line. We define user_in_db, our internal Pydantic model, that holds every field including hashed_password. We then define user_out, a second, leaner model with only ID, username, and email. The fake_db dictionary stands in for a real database. Now look at the decorator, at app.get with response_model set to user_out. The function itself returns a user_in_db object, pulled straight from the database, password hash included. FastAPI intercepts that return value, serializes it through user_out, and because hashed_password is not a field on user_out, it is silently dropped. The client only ever sees ID, username, and email. After your path operation function returns, FastAPI does not send that value straight to the network. It first feeds it into the response model you declared, using Pydantic's model_validate under the hood. Pydantic builds a new instance of that model from the return value, and only the fields defined on the response model survive. Everything else is excluded. If the return value is missing a required field or has a type mismatch, Pydantic raises a validation error, and FastAPI sends a 500 internal server error, because that is a bug in your server code, not in the client's request. As a bonus, the model is registered in your OpenAPI schema, so the interactive docs at /docs show the exact fields a caller should expect. Use response_model whenever there is a real gap between what your code knows internally and what callers are allowed to see. Passwords are the classic case. It is also a great fit when accurate OpenAPI documentation matters to your team or your API consumers. On the other hand, if your function already constructs and returns the exact public Pydantic model, adding response_model is redundant. FastAPI will already serialize it correctly. And if you return a streaming response or a file response, the filter is bypassed entirely, so response_model does nothing useful there. To recap, response_model is the parameter you add to your path operation decorator to declare what shape leaves your API. It filters your return value through a Pydantic model, so sensitive fields never reach the client without any manual effort on your part. The model also drives your OpenAPI documentation automatically. The main trade-off is that you maintain an extra model class, which is worth it when the public and internal shapes genuinely differ, and unnecessary overhead when they do not.